Look, I know you love your plasma table. I love mine. It was the workhorse that got me started in the little 2-car garage behind my house. The question is, how much work do you actually need to have before a laser makes more sense than that plasma table sitting in your shop? So let's dig into that right now. We've set up some practical shop floor benchmark testing to compare plasma versus a fiber laser head to head. But this isn't just any laser. We designed this 2 kilowatt machine specifically as the plasma killer. And here's the game changer. You literally can unplug your plasma table and plug this laser in. No special 3-phase power, no special high pressure air compressor, just laser quality parts that let you compete directly with the biggest shops down the street. And I mean, if you're anything like me, at this point in the video, you're saying prove it. So we're putting the clock on both machines. 10 minutes of pure production cutting, 1/4-inch mild steel base plates, because the difference might surprise you. We all know that lasers cost more upfront than a plasma table. I'm not here to tell you that. But do they really cost more after you do the math on those $30 consumables and the extra grinding time you're gonna have with your plasma table? Because here on the shop floor, we really just care about 2 things, speed and the part quality. When your customers are calling, you need repeatability and you need volume. So that's why we designed this 10-minute test. So to be fair, I called 2 of my buddies that have plasma tables and I went over to their shop and cut these parts for 10 minutes to see how many came out. I even went ahead and grabbed a rusty sheet to show you guys that the laser has no problem with rust, mill scale. It can even cut through paint, powder coat. I'm not cherry picking. I'm not trying to make ideal conditions. This is a real world situation with real parts that all of us need regularly. Freaking base plates, right? So first thing we gotta do is swap out the nozzle here. We've got automatic nozzle changer built in on every machine right now. And you're gonna have roughly about 4 or 5 different nozzles you're gonna use regularly on the machine. Now it's time to select our cut parameters. So we're gonna go up here to technique. We'll load all the cut settings in the machine for you guys. Anything new we need to set up, we'll do when we install the machine. Me and Justin come out there and we're gonna run through all the materials you guys have and have these all saved for you. So it's not on you to figure these out. So we're gonna hit blow, we're gonna purge out our gas, make sure we're shooting oxygen, not nitrogen. Justin's our sponsored driver today.
I've not been drinking.
Now that we're getting ready to cut, we've got our laser safety glasses on because this is an open bed machine and you don't want to be cutting without those. So the laser gives you a nice red aiming dot, helps you line up your XY0, very similar to your plasma table. Then he's going to hit frame. That's going to show us the outline of our nest, make sure we have enough material here to actually cut all these pieces. And from there, we're ready to go. So let's start our timer. We got 10 minutes on the clock. 3, 2, 1.
And no, you cannot see the red dot with these on.
And we got 10 pieces cut on the plasma table in 10 minutes. So pretty much that's a piece a minute. This is gonna tell us pretty quickly here in the first piece how many we can expect to get cut. Yeah, that looks good. Straight off the table, no more bevel. Not really much dross on the back to clean up. No dross on the front from the pierce. Maybe, I don't know, 15 seconds with a wire brush, 15 seconds with a wire wheel, and that thing's ready for fab.
And it's not super duper hot. I'd say that's 3/4.
2, 1, 0. No, leave it running. We'll get this last one out of here. All right, so we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and I hope you'll give me the 14th one, because I did give the plasma the benefit of the doubt on the last piece too. All right guys, here's the final result. We got plasma cut parts right here, laser cut parts right here. Pretty much what you should expect is plasma is going to have more slag on it. The edges are going to be rougher. There's also going to be this bevel right here on this edge. You see the angle that that's cut at, and you're going to have to remove all this slag with a grinder or a wire wheel. Definitely back here, this slag is not coming off. All that I can get to come off a little bit with my finger right there, but it's real heavy here in the corners. That's a typical plasma cut part. So here's front, back, side profile. Here we have the laser cut parts. We got 14 over here, 10 done over here in the same amount of time. And you've got no bevel anymore. That's a true 90-degree edge. Slag is very, very minimal. If any, it looks like this edge got a little munched, but it's very light. See, it's just coming off my fingernail here. So really easy cleanup, ready to go to your fab station. The productivity increase is not a big surprise to anybody that's been around these things, but one thing I do want to mention is this is the slowest laser we make. The 1.5 to 3 kilowatts are 1G machines, and our larger machines go all the way up to 2.5 Gs of acceleration, because we match the speed of the table to the power. It would be a waste to put really fast motors on this thing and make it zip around, because it just doesn't have enough power to use that much speed. So we're saving you guys money along the way. We have 3 different speed levels that match the basically 3 different categories of speed, from 1.5 to 3 kilowatts, 4 to 6 kilowatts, and 12 to 20 kilowatts are 3 separate speeds, so that you're not wasting any money on features that you're not really going to be able to utilize. But here's what we need to remember. The cost of a part isn't just the cutting time. Labor is the highest cost in every single fab shop in America, and consumables are a close second. So what happens when you grow from a one-man operation where you can work for free to get off the ground, but eventually you're going to have to pay someone else's labor to grind these parts? How does that change the math? Let's break that down real quick for you. So I went ahead and pulled the last 9 years of historical data out of our shop. The first 3 years we cut on plasma, and then the last 6 years we've been cutting on a laser. So our post-process cleanup time averages are 1:1 for plasma and 0.1:1 for laser. And what that means is for every hour of plasma cutting, we would budget an hour of cleanup time. So at a $15 an hour person, that's $120 a day before you paid taxes, Medicare, Social Security, all the back end stuff. So it's actually a little bit higher than 120, but we're gonna keep the numbers really simple here. The 1 to 0.1 ratio is for every hour of cutting on a laser, we budget 10 minutes of cleanup time. So every hour that you're cutting, you're spending about $2.50 in grinding time. Over the course of an 8-hour shift, that's $20 a day in cleanup time for a laser versus $120 a day of cleanup time for a plasma table. You see how the math is really starting to move around here? If you're cutting 3 or 4 hours a day or less, plasma table is still okay. You're not really losing money. It's just part of the game. You got to build up your volume a little bit more. As soon as you break over 5 hours of cutting every single shift, then the labor breakover really starts having a huge impact on your bottom line. Take that extra $100 a day that you're spending across 20 work weeks, and all of a sudden you've got $2,000 of labor cost that you wouldn't have if you're running a fiber laser. Let's talk about the next big cost, consumables, right? And this is where a laser really starts to take off after the labor number. Over here, I've got my plasma consumables. You guys are familiar with these. The Hypertherm ones are the most expensive. You can buy the Italian knockoffs, but either way, it's gonna cost you about $30 per set. The math we did is when we started tracking our restarts and arc failures, basically when these consumables start to wear down, the machine will try to pierce and you'll get an arc OK error and the machine will stop and you have to go back over there and restart it. Yes, you can pay somebody to sit there and restart the machine and you can save on the consumables, but at that point you're also paying an operator to sit there and babysit the machine, and he can't go and unload sheets, grind parts, fabricate stuff, cut parts, chase orders around the shop. He's not freed up to do any other activity. So you have to hold that labor cost and compare it against the cost of the consumables. We found that it was cheaper to replace the consumables on every sheet than to pay the labor to have somebody stand at the machine and babysit it and milk these consumables to the very end. You guys are gonna have to make that decision for yourself, but either way, these are 30 bucks. There's no way around it. Over here, we've got the fiber laser consumables. You're gonna be burning through a lower protective lens that goes right here in this little green door on the laser head. And this thing costs you about $6 and will last about a week. Then we've got our nozzles. These guys right here cost about 25 bucks and they'll last you at least a month. So we go from $30 a sheet to 20 cents a sheet, something like that. Depending again how much you're cutting, doing 5 or more sheets a day, all of a sudden that consumable cost really starts to add up. $30 times 5 is $150 a day. $150 a day times 20 days. You guys do the math, it's huge. Where on a fiber laser, you've got 4 of these $6 lenses and you're gonna be burning through about 1 of these $25 nozzles a month. So now which machine looks like a raw deal? Comparing a $20,000 plasma table that's cheap up front, but more expensive to run in your shop every day versus a laser that's more expensive up front, but saves you money in your shop every day. Because these consumables are eating into your profits faster than you think, especially if you're on plasma.